Right, everyone can hear me, great. So you can see already that they are scary. There's some parentheses here. So I guess I'll start by saying what's JURL. Well, JURL is just something fun I made. It's a no dependencies implementation of curl, not really all of curl, just some functionality of curl, and also it has some basic SSH functionality, so it can execute some SSH. Really, the premise of the talk isn't so much about JURL. It's more that this was my first time really doing any network protocols, and I found Node to be super easy to learn how all this stuff works, and I'm kind of wanting to encourage you to try it yourself in Node and have a bit of fun. So let's kick off with some motivations. So people always ask me about this, like, why bother? Well, the main reason is, like I said, I didn't know anything about networks. For a bit of background on me, I've been programming about a year now. Used to be a mathematician. You'll probably guess that when you see the slides. So at work, we have this proxy, Squid proxy, and it caused me like untold number of problems when I started. So I went on holiday and I decided, right, in my spare time, I'm going to learn a bit about networking, and then I'll never have this problem again. Another reason, well, I use curl a lot at work. It's very helpful. What would be even more helpful is if it was written in JavaScript, and then I could just play around with it however I liked and get any functionality out of it. Another reason, well, I call myself a Node developer at work, but really I hadn't played too much around with the core Node modules. Like maybe I'd used FS, maybe I'd used a few other things, but I hadn't used really like net or TLS or any of the really cool stuff. And I guess the final reason is just to have something else to do on holiday with my dog. That's me on holiday with my dog. Yeah, okie dokie, so I had hair then, you can see. So let's see what we're going to discuss. So it's sort of pretty functional. What I'm aiming to do is sort of go through my journey, I guess, and say, okay, here's what I did, here's how it looks in Node, notice how easy it is to do in Node, and then you go away and do it yourself. So the first thing, super simple, is just implementing sending a file. That's multipart form data. Something equally simple is just making an HTTP request over HTTP proxy. I'll talk about how I wasn't really happy with what this revealed to me. Then I'll talk about making an HTTPS request over HTTP proxy, which revealed how this tunneling business, which sort of eased all my woes. Then I'll talk about the SSH protocol, the sort of lessons I learned there, and yeah. And then we'll finish up with some lessons learned and some remarks. So I'll just start by just showing you some basic functionality of JURL. Let's just do some basic JURL. So we can JURL google.com. Oh. Okay, you know, that's nice and simple. We can see we get the response. Oh. Blimey. There we go. So we can also go to an endpoint and sort of get the response and pipe it into a file. So that's what I've done here. So this has just downloaded that file for me. We can also do this command here. I won't try and copy that one. So that command should go to all those endpoints. So this is sort of some functionality of curl, which is that it has sort of a match, some regex-like thing you can do where this would go to Google and ask.com, and also it would go to google.com and search where the search parameter was the numbers 1 to 4, going up to intervals of 3, and then it would put it into these various files that I create. So it would go into google.html, ask.html, goog1.html, and goog3.html. And you see there's just this -- location header part just to recursively follow the location header so I really get to my destination. Okie dokie. And then we can see some SSH. So here is an SSH server that I have. Okay. So I can go into there. I can execute a command. Let's say just ls. Okay, I can see the various files in there. Okay, and maybe I can cat a file. Okie dokie. So I can do whatever I like. So that's essentially the functionality of JURL. Of course, I could also curl from my SSH machine and get all the actual functionality of curl if I liked. Okie dokie. So moving on to how it looked. So let's start with something simple, multipart form data. So this was just the first thing I encountered. You know, how do you send a file? Well, in reality, it's kind of easy. You just make a form, have a server which can listen to the request that the form makes, and there you go. You'll see exactly what the browser does. All the browser does is just generate a random string which is going to act as a boundary, and then basically the files are separated by this boundary. Yeah, so that's great. You can just infer from that and make something super short. We can see how it looks in Node. You know, it's extremely easy thanks to FS and streams and the like. Oh. So if we go to so we go there, you see all we have is we just have this bit up here, which is sort of going through the files that are passed through in the command, and then it's piping each one in. There's only really one subtlety, which is we don't want to emit the end event on the socket, so I just have to, when I pipe it, I just have to make sure I don't emit the end event. That's all this end false is doing. So really nothing complicated, like, you know, I want to pipe a file in, Node does it easily for me. Okay, so here's the first lesson, which is that I did all this initially just by kind of guessing. Like I said, I just went to the browser. But sort of the moral of the story is that really you should be using this IETF, which is sort of a place where you can obtain a number of documents which will explain every protocol to you. You can just read these. They'll tell you exactly what to do. So you'll see later that's what I did when I implemented SSH. You just read them, follow the instructions. Okie dokie, so now moving on to making an HTTP request over HTTP proxy. Well, I'm sure most people that weren't me know that this is extremely simple. You basically just do the most naive thing. You're going to make a request to the proxy. You're going to tell it, I want to talk to this. It's going to go, get the result, and then send it back to you. That's kind of simple, but when I worked out how to do this, I wasn't really happy because, okay, that's fine for HTTP, but I kind of don't understand how that extends to TCP because, okay, HTTP, that kind of feels like I'm just sending one thing and getting one thing back. Fine, but I don't understand how that extends to TCP. And also, I realized there was sort of a problem with it, which is that, okay, well, let's say the proxy is talking to something HTTPS. Well, then the communication between them is encrypted, but what about back to me? Well, that won't be encrypted. So I could see that this couldn't be the be-all and end-all of solutions. So I sort of persevered on and learned about HTTPS. And this sort of solved all the problems. So it does the second most naive thing. And well, what's the second most naive thing? Well, maybe it's the most naive thing. We have this connect method. I'm going to talk to the proxy. The proxy is going to establish a TCP connection to my endpoint for me. I have a TCP connection to the proxy, and then I just send the packets down that TCP connection, and it forwards them for me. And this is great. I was super happy when I found out this, because this explained everything. Like now I could see it was easy how to proxy anything. Like essentially I just established this TCP connection, and there we go. It's like I don't have the proxy in the way at all. Okie dokie. So this means that we finally get to see some relatively cool Node. So what's some cool Node? Well, that's HTTP agents. And this is just sort of a neat way that Node provides of implementing what I'm talking about. So first of all, for those that don't know what's an HTTP agent, well, an HTTP agent is the thing in Node dealing with the HTTP and HTTPS library, which sort of handle your sockets for you. So it creates and manages them and stuff. And the most important thing, well, okay, it supplies its own, you know, the global agent, but you can make your own and supply that. And the most important part is that you can override the method which supplies the socket to you. So this is this create connection method. So all we have to do is just override this method to make it go to the proxy and make the connection. So I can show you how that looks. Super duper easy in Node. There couldn't be anything easier really. Like if I go here, you see all I do is I just do exactly what I described in very plain English. I'm going to talk to the proxy. So here I make an HTTP request. It's a connect request. So that's going to make me a connection. Once I get the socket back, I'm just going to use that socket. And let's say I want to upgrade to a secure connection. Well, I can just send the TLS.connect down that socket. And there we go. I've established a secure connection over proxy. And you know, this is all you need to do. Like you just pass this the corresponding agent from this. So of course I extend HTTP agent. override that method, and there we go. When I use that agent, it's all going to work nicely. Oh, yeah, sorry about that. Okie dokie. So just a little snag. So this isn't really a snag at all. This is, again, something that probably everyone knows. So essentially, I'd done all this. I was playing around. Then I went to work and tried to use it at work and discovered that it didn't work at all. And I was quite confused. And it ended up being something quite simple. So the reason is basically just this SNI. So for those that don't know, an IP address might be hosting multiple web servers. Well, how's that IP address going to know which web server you want? Well, normally in HTTP land, you send this host header, and that sort of tells the IP address, okay, they want that web page. So that's fine. It doesn't really make sense in HTTPS, though, you can see, because we're going to do all the security stuff before we send the header. So sort of, how's it going to know which certificate to present us? You send the certificate, like it sends the certificate corresponding to the site. And well, if you don't send which site you want, how will it know? So yeah, there's just a solution to this. It's this SNI thing. It's a fancy name for something that isn't very complex. The moral of this isn't SNI is this great thing that you have to be aware of. It's more that I was sort of being quite silly in my approach to networking. I was sort of just playing around, guessing as I went along. Really what, in retrospect, I should have been doing is reading fully the documentation, and I would have easily stumbled across this. I mean, once you know what you're looking for, it's very easy to resolve. The TLS connect method just lets you supply the server name, and it deals with all that nonsense for you. Okie dokie. So I'd done all that. That was cool, I guess, except that it kind of felt like it was still quite basic. I guess it just, yeah, like it didn't seem interesting enough. Kind of when I initially started this, my interest was, okay, I'll write some manual requests, like writing the packets and stuff, and then maybe I'll have a good feel for networking, and I'll have at least a good intuitive grasp, and that should be enough. So I chose SSH. So SSH isn't quite like TLS, as far as I understand. You can't really use the TLS stuff. SSH, as I understand it, came before. So before SSH, I was thinking of doing something like FTP. So if you look at my code, you'll see that there's some stuff that does FTP, but I kind of wasn't very interested in FTP because it's just another plain text, or text-based protocol like HTTP is, and sort of seemed a bit too boring and simple to implement, and not that practical for me because I don't deal much with FTP. Oh. So yeah, so we've seen, or I can tell you that you've got this net module that creates TCP sockets for you. You've got buffers in Node, so I can just write all the packets. Like I can just write packets, pass packets that come through to me, and well, any protocol is kind of simple to implement. I just have to follow the rules. So that was my revelation. Well, I'll just look it up and go it. So all nice and easy. Of course, in reality, I know that it's not easy, or at least I don't think it's easy. So SSH is a complicated beast. My SSH client, if you'd like to call it that, doesn't do nearly what it should do. Some spoilers, it doesn't bother to even verify the HMAC that I get sent back. I just wanted to get the results. That was me. So all I was aiming for is I want to be able to execute a command on a Linux SSH server over a proxy connection, and I wasn't going to deal with certs or anything. I was just going to send a username and password, and I wasn't going to implement lots of key exchange algorithms. All I do is I just decided I'll pick the most popular one, which when I looked it up was elliptic curve Diffie-Hellman. This is one that the SSH protocol sort of demands be supported nowadays, so I thought if I do that, I'm in good stead. And now I actually had to do my reading. So I would show you this, but I had some difficulty moving the things over earlier. But essentially, these documents tell you everything you need to know. Like if you go to this page 7 of this document, it will tell you, okay, here's what a packet looks like. It starts with a 32-bit unsigned integer that's going to tell you the sort of total length of the packet. There's something that tells you, I guess it's a 8-bit integer, which tells you the length of some padding that you're going to put on the end. It tells you some rule about what the size of the packet should be. And then there's a payload. All simple stuff. And maybe like you want to know, okay, well, what's the first packet I send? Well, it tells you exactly. You should start by sending this packet, which says sort of, I'm this type of SSH thing, and what type you are should satisfy some rules. Okay, what's the next thing you should send? Well, you should start exchanging which algorithms you support. So there's a big packet you've got to send which says I support these algorithms, all of these algorithms. So you're going to be sent one back, and you have to sort of pass what you're sent back. So we can see what that looks like. So super messily written by me. Apologies for that. Let's see. So I suppose it should be in SSH parsing. Where's that? Oh, yeah, okay. So that's a spoiler for some crypto. Let's see. So here's me passing. No, that's the EC key. Right. So here I just want to pass the key exchange, and really it's just a lot of words doing nothing. Essentially, I have some code up here which is going to pass a packet. That's just what I described. Like I just know how the packet's going to look, and then I just go through the packet. I've been told exactly how it's going to look, and I just read out the relevant things. So actually, a feature I didn't show of this, I guess I can show it now, is that if I pass in the -v flag, obviously this isn't terribly useful, although it can be useful for debugging, is I can pass in the -v flag and see, okay, these are all the packets I'm being sent, appropriately passed. Okie dokie. So that's reading the IETF, and really, henceforth, it was just kind of a matter of reading IETF. And this is what I want to stress upon you, is that it's super duper simple. Like, in my head, there was all this mystique around a network protocol. It was like this complicated behemoth that you had to study for the rest of your life to know about. But in reality, you just read the documentation. It tells you exactly everything. It's kind of one of the easier aspects of life. Of course, something that might not be easy is the cryptography stuff. But the good news there is that Node does it all for us. So Node has a crypto module. It's extremely powerful. All you need to do is just understand how to put things into it. So, for example, part of the SSH algorithm is that you need to create an exchange hash based on various things. So what those various things are can again be found in an IETF. So here I'm using the exchange hash. So here I'm actually creating the exchange hash. So if you read the documentation, you'll see that essentially when you did your key exchange, you said which hashing algorithm you were going to use. At some point, you decide to generate this exchange hash, and it's just formed by concatenating a bunch of information you've received before and hashing it. Simple as that. And you can see that all the stuff dealing with cryptography is equally simple. Like, it's just lots of lines which essentially generate the thing that I can use for decryption and encryption, and then I never have to think about it again. So the node module does all the heavy lifting for us, and all we have left to do is just follow the protocol to the letter. So this is where you can slip up if you're rushing into it like me, because, for example, you might be trying to guess what things look like, and that's not really possible. Okie dokie, so here are on to my final thoughts. So final thoughts are that you should go to IETF. I suppose I've talked about it enough now. Another thought is that Node is like super awesome. Like, after I've done this, I've done it in languages like C, and that's considerably more complex in my opinion. Node just kind of gets rid of all the unnecessary complexity and just leaves you with what you've actually got to do. So here in the talk, I've only demonstrated things using TCP, but actually you can easily do UDP as well. So for example, I played around a bit. This is nothing fancy. This is just one can make a DNS request if they like easily in Node. So let's see what that is. Yep. So here you see me. This is just some very rushed code where I make a manual DNS request to Google and resolve the IP. So yeah, UDP equally simple to sort of play around with. Again, I'm not trying to assert that anyone should dip their hand in this and try and make something production level. I'm saying that for the purpose of having a good understanding or a reasonable understanding of how things work, it's a good way to go. The moral of the story is that you shouldn't rush into these things. I sort of rushed into making my SSH client, and because of that, it's not very well written, in my opinion. If I were to go back, I would definitely be using streams to handle things. You could do it a lot more nicely with that. And I probably wouldn't have tried to rush to my exact goal. Like, I was trying to just execute a remote command. But really, I think I missed out on a lot of nice details by just trying to do that. I really should have done the full generality of a proper SSH client. And yeah, so network protocols, simple, very finicky. you can play around with them. I wouldn't feel bad if you leave the proper implementation of them to someone who's been doing it for all of their life. And that's my talk, so any questions?